Hello everyone, my name is Erica Johnson and I am the managing editor here at PV Magazine and the moderator of today's webinar, Next Step in PV System Design, Tools with Cross-Manufacturer Input. Today we've developed a great program for you that has received a lot of interest and participants from all over the world, so thank you so much for joining us today. Project system design and planning can be tedious work that requires a significant amount of time and expertise to deliver a high-quality project, as many of you know, which makes it crucial for companies to be able to develop and be successful in the quality of the work that you do. Let's really face it, project planning can be a headache using various softwares, workflows, and necessary items to bring together a project from concept to delivery. Can be really challenging for both system designers and integrators alike. Mounting manufacturer K2 Solutions has really identified this industry pain point in project planning and built a free new digital tool and software solution that allows for cross-manufacturer inputs, which we'll be providing a comprehensive demo on today. I am joined by Stefan Kuhl, Business Development Manager at K2 Systems, along with Gal Roeder, the Product Manager of Industry Partner SolarEdge, both of who are leading experts on the K2 Plus platform. We have a large number of participants today, and this is really your opportunity to engage with the experts and have your questions answered on this new planning tool. So I encourage you to submit any questions that you may have throughout this presentation, and we'll work to have them answered for you. So without further ado, I'm going to go ahead and now pass this over to Stefan Kuhl, who has been significantly involved in the development and the expansion of the K2 app. Stefan?
All right. Thank you, Erica. So on behalf of K2 Systems, I'd also like to welcome everybody, and I'm glad that so many of you guys joined. Today's topic is Get Connected, Simple Design, and Cross-Manufacturing Features. And in the beginning, I just want to show you our agenda really quick. So for those of you who don't know us yet, I'm going to start with a brief introduction of who we are, what we're doing, and then get on to explaining why digitalization is quite important also in the solar business. And in the end, we'll do a live demonstration of the K2 Plus feature in correspondence with Gal from SolarEdge, which I'm quite looking forward to. So K2 Systems at a glance. We're a global mounting manufacturer, and as specialists for rooftop applications, we offer effective and economical solutions for roofs all around the world. And of course, we provide very fast, reliable, and professional support for our customers. We do have roughly 150 employees and are a two-brand company. So in our 6 main markets, like Germany, France, Italy, the UK, South Africa, and Brazil, we're operating under the brand name K2 Systems. And in the US and Mexico, we operate under the name Everest Solar Systems. We work with roughly 100 distributors worldwide, and our structures have been used for more than 9 gigawatts of installed capacity, which, if you consider that most of those are actually rooftop projects, is quite a lot. So just a quick glance. Oh, okay, there is. Just to give a hint about how global we actually are, all of those countries marked in red is actually countries where our structures have been used before. And it's more than 120, so quite a lot. And just some reference pictures for you to see. So I would like now to go on and move to the digitalization part. First of all, a quick introduction of why the mounting structure is actually important. So the mounting is actually one of the most crucial parts of the installation, which is often overlooked. But you always have to consider mounting is the one thing that is actually holding your modules on the roof. That means it's the one thing that ensures that the investment that you or your customers did will be there and is going to work for the whole lifetime of the project. So it is really important to focus on that. And that means that you always have to do a structural analysis for the structure. And that one needs to be project specific, just like the string planning. So now let's move ahead. Why digitalize? As an introduction for us at K2, we think that digitalization is a way of further focusing on customer needs, right? And for that, in the beginning, we of course have to understand our customer, then design the experience for them, and basically save time on behalf of the installer. So the main goal of the whole digitalization in any branch everywhere around the world is basically to simplify everything, in our case, simplification of the planning process, in order to enable our customers to do more installations. And of course, we continuously take the feedback that we get and put that into our tool to further improve it. So just to give you one example of why we do that is, if you have a look at the pictures shown here, it's everything that is necessary for a safe flat roof ballasted mounting. So on the left, for example, you see wind tunnel tests, and that one is really necessary to examine the complex flow behavior the wind has, all right? Because there's some areas of the roof where there's wind turbulences and others that might be shadowed, and we need to take that into consideration to actually calculate for wind pressure concentrations and reductions that happen on the roof. And but that's just the one part, right? The other part that we also have to consider is the load-bearing capacity of the structures that we have, and we test that and get that through extensive testing. And I could go into way more detail here, but basically it's very complicated. And to ensure that our customers are able to use our products, we have all that knowledge and we put it in our tool. So we're trying to simplify it and automate it for everybody to be able to use it and still be able to get all the good knowledge that the expert tools have. So just a quick overview of our planning software. It's named K2 Base. We've been using Base as a planning tool for a lot of years now. Since 2 years, we have it online. It's a free planning tool. It's based on Google Maps, and it just takes you through the whole planning process of a PV installation in 5 easy steps. So from the beginning of deciding where you want to place, where your project is at, on to the bill of material in the end and the structural verification. It's quite accessible. We have it available in 15 languages, and it offers a detailed load planning, including structural validations according to different national standards like the Eurocode or the US code, and so on. So, but that's basically just one thing, right? So we got the planning part covered already, and then we also thought about how can we enable our customers to talk about structure, because mounting actually can be quite complicated sometimes. So we thought, let's take everything, all the information that we have, make them easily accessible, and put them in our app, which is of course also free of charge. And the reason behind that is we're able to visualize a mounting system, and we enable our customers to talk about safety to their customers. And I think safety for a PV installation is one of the main unique selling propositions that you have to stress. And one quite new feature that we're having is actually the roof check, which is currently being implemented, which enables our customers to gather data that they need for planning, like the site, building details, while they're talking to their customers at their premises, and then later on automatically have those values in our planning tool and start the planning process. So that's what we already have, but of course we always want to take it one step further. So we went back and actually re-examined the planning process that you guys and everybody else has to go through during a PV project. And what we've noticed is, worst case scenario, you have to work with 4 different tools. Like you have a tool for the yield calculation, you have tools, software for the mounting systems like our K2 Base, there's inverter design tools like the SolarEdge designer, and in case your customer also has that, you also have to consider working with smart home tools. And especially between the mounting system part, so the mechanical installation, and the electrical, the inverter design, they can be quite heavy amount of manual loops that you have to do, right? Because you have to make sure that the mechanical part and the electrical part are aligned, so you don't run into problems on site. And therefore, if you want to do it correctly, you always have to blend both. And if you hit constraints in one part, you have to redo the project in both parts as well. Like if you want to have to delete some modules there, you would have to delete them in the other part as well. And everything that you do there has to be done manually, which is prone to error, right? And it takes just a lot of time. So most of the time, people might not do that. And that's where we thought, let's make it actually easier. And the solution that we came up with here is called K2+, which basically is an interface between the mechanical and the electrical planning. And the interconnectivity there ensures for an easy transfer of layout changes. And that results in a reduction of complexity for our customers, which means that the planning time is of course decreased. And you all know that less planning equals more installations. And one big plus about that is the customer gets the expert knowledge of the manufacturers, right? So in our case, if you plan using K2 and you plan on using SolarEdge, you will be able to do that in the expert tools. And therefore, those tools, they have been optimized to make sure that mounting, for example, in our tool is optimum, as well as the inverter design and the SolarEdge designer. And that is one of the biggest pluses that we can have here. So without further ado, I would now like to switch to the live demo of the simple planning, unless there's some questions at this moment.
Great, thank you so much for that comprehensive overview, Stefan. One question that did come in surrounding this is, how does this compare really with other softwares that exist currently for design and planning?
Mm-hmm. Well, if you take, as I just said on the last slide before that, what we have is a tool that has been specifically designed to our needs. That means it has been done to our standards. It has all the expert knowledge that we have in there and is continuously improved according to our structures. So it's definitely the way to go if you want to do a really good project. And I think the same goes without saying for the expert tools that the inverter companies have, like SolarEdge, for example. So if you combine that and you plan in those tools, and it's quite easy to switch between those tools, you make sure that you get the best of both worlds instead of having one software that kind of meshes everything in together, right?
Sure, yeah, great. Thank you for that. And also, I think an important factor is that this is a software that's free for companies to use, correct?
That one as well, of course.
Great.
All right, any other questions, or should I continue?
You can go ahead and continue now.
Okay, perfect. All right. So I'm just going to go through a really nice and easy project there today. Nothing too complicated. For those of you who haven't used our tool K2 Base yet, what you can do is register yourself if you go to the URL up here. Basically, registering is quite easy. Let me just show you real quick. All right, so once you enter for the first time, you have the possibility to sign yourself up here. And we usually approve your account within 24 hours. So after you've been verified, you're free to go and start the planning process. Just gonna go ahead and log in again. As I said before, the tool is free of charge and available in 15 languages, which can be easily switched up here. So in case anybody here knows Japanese, you could easily go ahead and plan with that one as well. So, but I don't, so I'm just gonna go back. All right, so the first part is always deciding where your project is at. As we can see here, Google Maps based with the autocomplete of the address. For today's project, I decided to show you a nice little city in the southwestern part of Germany called Saarbrücken. There it is already. So You can just go ahead and auto click. You can then move in. I'm just going to do a real easy flat roof today, the one over here. Okay, so in the beginning, you have the possibility to add some project details. I'm just going to name that one PV Magazine webinar. You have the design method. In this case, as it's in Germany, it's designed according to Eurocode. So as I'm the author, I'm just going to input my name and some random company. All right, so we got the project tab already covered. And after that, we move on to the roof part, which can be done by clicking up here. And there you can start drawing the roof on the actual satellite image, right? Which enables you to plan without having to actually go on site. So also great time saver. Just gonna start drawing. In this case, you have the option of different roof types. This one is a flat roof, so I'm gonna go ahead with that one. Then the roof shape and the roof covering. So just a second. All right. Seems to be a small glitch here. All right, there we go. Perfect. So once you did the drawing of the roof, you might notice that the roof is probably not really 31.31 meters long. So you always have the possibility to switch to 2D view mode, where you can input the correct dimensions. Like, let's assume this one is 32 meters long and just 16 meters wide. Then you have to input parameters like the building height, the roof pitch, and in case there is any, also a parapet wall height. The next one is marked red. It's the friction coefficient. This one is actually quite a crucial part for a flat roof structure, because if I want to explain it in layman's terms, it's basically what decides how slippery a roof is, and that greatly influences how much ballast you need to add in the end of the project. And if you guys are interested in that one, we have a quite easy explanation in a video online showing how to do that. All right. So,
and one question that's come in, Stefan, is it possible to import roof designs from existing CAD files?
Not yet, but it's actually a feature that we're working on.
Okay, great.
Okay, good. So you can also add some abstractions in case you want to. I'm just going to skip that part here due to time constraints, and also remarks that will be added in the PDF report they can generate in the end. So once we're done with that part here, we can then move on and go to the design phase.
Excellent.
And for the design phase, we just need to wait a little second. We have implemented a new database for manufacturers of modules, as well as the module types. It's the same one that SolarEdge as well is using, so it's easy to get the data from us to SolarEdge as well there. Just going to use that one here, and then you can draw the roof. As you can see here, there's different options of systems available, and if you hover over the system, there's nice tooltips coming up explaining what exactly that one is. Right? I'm just going to go ahead and do a DDOV. It's basically our newest east-west system for flat roof. Just going to click add, and then like before, it's just simple drawing. So once it's calculated, I'm going to make this a little larger. I want to have 11 modules here and 6 columns down here. All right. Then there's other possibilities I can input, like the type of clamps in case it's a black module. Just going to put it in the middle of the roof here. What is actually quite nice to do in case you want to have maintenance gateway and gangways in between, you can also add those. There's already an existing one, and you can just widen them to your needs, right? So I'm just going to go ahead and put 500 in here. After it's done calculating, you see the space here is now larger. And you always have the information of how many modules do you have on the roof down here. So just want to have 11 up here. All right, perfect. So we got 132 modules with a total of 34.32 kilowatt peak. The next part is the loads. In this case, it's quite easy because for Germany, we do have automatic determined wind and snow loads. So the tool, again, makes it really easy for a user because it automatically knows where you're located at. And therefore, you can't really input wrong parts here. Right, so
that's great. And then what grid codes are applied when designing in the software?
You mean building codes?
Yes,
Or,
correct.
okay, so in this case, we're located in Germany, so the design method is shown up here. It's Eurocode with a German annex. Okay?
Okay, great. And then you have codes applied through globally as well?
Yeah, we do. Like Europe, for example, most of the national annexes, we do have the Japanese code as well. We're currently in the process of implementing the Brazilian one. Of course, the US code is in there. And we also have the Japanese and the South African one.
Great.
Okay. So everything here automatically, also the ground elevation. So nothing really to do for us, which I personally prefer. I like it nice and easy. Okay. So if you guys remember the part that I showed you earlier about the flat roof being really complicated, that's basically what you get in the end, right? It's a ballast plan explaining you where exactly you have to put what amount of ballast in order for the system to stay in place. And this is really crucial because you don't want to add less than necessary because that would be dangerous. And you also don't want to add more than necessary because ballast costs money as well, first of all. And sometimes you might not even be able to build the actual structure there because the load bearing capacity of the building might not be strong enough to do that. So we got the components up here. Just going to skip those. And the system details down here. Once again, number of modules, the output, and the loads on the modules. And quite important, the verification of the system. And in this case, everything's in order. We are 100% clear to build it like that. So we can then move on to the summary page, where you would have several parts of possibilities, like over here in the roof section. In case you have more than one roof in one project, all of those would be shown individually with a number of modules and the power output. You have the bill of materials down here, which you can edit in case you want to have some spare parts. Like let's say I want to have 80 of the DDOMV bases, I can just apply that. And you also see that you manually edited that. So in case you open the project later again, you see that you did change something here. Then the most important part of this whole planning is, of course, the report in the end, right? Because you need something that you can show to your customer. And this one you can customize quite nicely. You can input the project data, assembly plan, the ballast plan. You will get the results, and most importantly, the structural analysis of the whole project. And of course, also the bill of material. It's just a simple PDF. I'm not going to download it now. You guys can check that out later. And I would like now to show you how easy and simple the new feature K2 Plus is. And for that one, you only have to click here on the inverted design, where you can then choose an inverted design tool. I'm just going to go ahead and choose the SolarEdge designer down here. Takes a few seconds. And everything is sent over to the SolarEdge designer. Just 2 clicks, all right? And that's the part where I would like to move on to Gal, because he knows the designer better than I do. So he's the guy to explain that.
Great, amazing, very simple.
Hi, so I hope I'm being heard loud and clear. Great, that's great. So thank you, Stefan. So first I'd like to, of course, thank you for inviting me to participate as a panelist on your webinar. And I'm super excited to demonstrate together this collaboration between our design tools. So we at SolarEdge offer for free our online design tool, for installers, EPCs, design professionals, streamlining the design process, but we lack on the mounting specifics. So as you can see, right after Stefan exported the design from the base tool, immediately we created the exact project with the exact, if I'll go to the PV module placement here, one tab before, we reconstructed the same PV layout. So this is the east-west system of K2 systems, the racking. We can immediately continue just for the electrical design, meaning to select the SolarEdge inverter, the right power optimizer, and get an energy simulation. So actually, when I'm looking at this reconstruction of the layout, I can also use the satellite view. I can see, for example, that I think we can manage to squeeze in another row here of east-west. So, Stefan, do you think it will be possible now to edit or update this design and add one more row?
Yeah, of course, no problem.
Okay, so let's do that. So if you can take presenter rights, yep. Yeah.
I just did. All right, so I'm just gonna go back to the design part and add the requested row by simply putting it here. And then it's already there. All right, so we can go ahead to the results. So as we added another row, of course, the ballast needs to be recalculated. Still everything looking good. And I'm just gonna send it over to you, Gal.
Great. So I'm actually opening the design on my end, and you can see how immediately this change was reflected. And now I have 144 modules. So I'll click on the electrical design tab, and I'll do the electrical design of the system. So the system will give us a recommendation of which SolarEdge inverter and which compatible power optimizer will go along with the inverter and with the selected solar panel. So I can see that I can get nice DC-AC oversizing ratio using the SE25 with P600 in a 2-to-1 setup. It means I can place one power optimizer spared 2 modules. So I'll just click on generate. And now as a final step, I'll just need to string the modules, connect the power optimizers in strings to the inverter. So using our string tool, I'll just click and drag over the modules. And you can see, since they are in a 2-to-1 scenario, so each couple is actually considered as one optimizer. And I'll do them alternating, since it's an east-west racking. So I'll prefer to create strings of the same orientation. And you can see that the string is, as I string it, it's in red. And the system is telling me that the string is too short. And I can see here in the system gauges below the valid string length size and the maximum string power. So I'll continue to create the string. Now it's in green, it means it's valid. But I will try to create actually slightly longer string. So let's say 42 modules in the first string. Now I'll create the second string, again by clicking on an unwired module, holding the mouse left button and dragging. So now my second string is valid. And let's put another 42 modules. Then I'll do the third string.
Great. And a couple of questions came in surrounding whether it's required for a SolarEdge design login in order to export the design from the K tool into the SolarEdge tool. Can you clarify that?
Yeah. Yes, exactly. Absolutely. So, yeah, we do require a SolarEdge credentials, meaning you need to sign up, but exactly the same as the K2 base, the registration is completely free. You can sign up, and then when you do the export of the design from the base tool to the designer, you will be requested to enter your login credentials once and to be signed in into SolarEdge.
Okay, great. Thank you for that clarification. So on both ends, it's a free tool for individuals to use.
Absolutely. So I've completed the wiring of the system. I can see that the inverter is 134% DC to AC oversized, and the all of my modules are wired. So I can go ahead and hit the summary and reports button, and this is where the designer runs an annual hour-by-hour simulation. So we provide the report that can also be served as a customer proposal that can be printed out. So we see the installed power. This is in kilowatt peak based on the module's specification. The max achieved DC power. So this is the actual DC power that can be achieved based on the location and the positioning of the modules. We have the DC AC oversizing, the max AC power of the inverter. So this is an SE25K, and the annual energy estimation, including the monthly breakdown. I see that we have usually it's in the summer months, we'll have some clipped energy, meaning that at a certain point in time, the DC production is higher than the inverter threshold. So this energy is clipped, but it is less than %. So I think it's great. Scrolling down here, we also have our system loss diagram where we show environmental losses, the DC losses and the AC losses, a summary of the modules, and a bill of material, which is the bill of material for the SolarEdge equipment. So it completes the bill of material that you got from the from K2 base. And this is the bill of material for the inverter and the power optimizers. We also have a nice description of the electrical design. Additionally, just another benefit you will get using the SolarEdge tool, apart from being free and the SolarEdge, the SolarEdge tool, we also have integration with other SolarEdge software products. So when the system is installed, you can also export to our monitoring platform. It will create the system on the monitoring ready for mapping and commissioning. So I see that, yeah. So just to recap, I think we tried to do the design process as simple as possible, and I believe now it got even simpler with this cool cooperation between our design tools. So with that, I'll be transfer back to you.
Oh, sorry for interrupting. One other question that came in for you is there an option, or how does this participant choose or designer choose the optimal string size for the SolarEdge inverter? Is there that capability through this product?
So yeah, we already incorporated in the designer while you're doing what we call manual stringing, where when you create the strings, and for example, now I can double click this string and now it's like in stringing mode. We provide here the design rules, for this optimizer with this module and this inverter. So you can see here the rules that will guide you. For example, with this configuration, between 26 and 60 modules can be connected to a single string, and up to 11.25 kilowatts of string power. When it will exceed or be below, of course, this range, the system will alert. Additionally, we're now also working on string length suggester, like an assistant that will recommend the size of each string. This is when manually stringing. And we're hoping to get really soon the auto string functionality, especially for larger systems. So we'll have an auto string functionality in the designer that will try to balance the string and do the optimal stringing for the users.
Great. And then is this easily exportable for a good print copy for an engineer that's going to be on the roof to look at this?
Okay, so currently we have two report options. One is the project summary, which is, as I said earlier, it's kind of a customer proposal. So it's less technical for the installation crew. The second report is what we call a string design report. So here we have the map of the strings and how they are connected. I think we will pretty soon we're going to improve also the layout of this report, but this is exactly the purpose of this report is exactly this, to be like a technical or a mechanical string report where you can go on the roof and see how to connect the modules.
Okay, great. And then one other question that had come through is whether it's possible to actually automate quotes within this as well and cost estimates.
Currently we don't handle the financial. I think we will address this topic as well and add financial calculations. But for now, we focused on the energy savings. Like you can optimize your design to maximize self-consumption. For example, with the designer, it's also possible to enter the user consumption information, select the load profile, and then also design with our storage solutions, add a battery, and optimize the system. But this is in terms of the energy, and we will introduce later on the financial features.
Okay, great. Wow, it's so interesting to see how far the industry has come in the design, using these online technologies and tools, how far the industry has come with design and planning over the recent years. Okay, so now we'll go ahead and kick it back over.
Sure.
And open it up to question and answer and further this discussion. So quite a few questions have come in to whether or not this takes into account shade obstructions, which of course is a large factor for designing systems.
So yeah, the designer that does the simulation, the energy simulation, does take into account shading. We have shading analysis during the simulation process. Currently, we have limitation on the number of modules because of performance reason, but we're working on improving that. So if your system has less than 400 modules, then we run the shading simulation, splitting between shading irradiance losses and shading electrical losses. And they will appear in the system loss chart in the summary and report section. Above 400 modules at the moment, we just disable the shading analysis and we write it on the report that we didn't run the shading analysis. And just another shading feature that we provide in the designer is in our PV placement tab. It's possible to use, we have an irradiance map where we show in like a color coding a heat map on the roof facets, and we also take into account any shaded object. So if, for example, we would have in the base defined any obstacles, we would have seen the shading effect on that.
Exactly.
Amazing, amazing. And where does the irradiance data come from?
We use weather data, meteorological data from Meteonor. And also we have, of course, the exact location, so we know exactly the sun position along the year.
Yeah, and in our design tool for the shading, you also have the option to simulate that one due to the exact location being known. So also in our tool, you can do that in the beginning. And
Okay,
then,
great.
of course, hop over to SolarEdge and do the irradiance losses, etc., a little bit more in detail.
Okay, great. And it's very easy to send as another question. Maybe this participant came in late. That the SolarEdge results are sent back to K2 and made available in the K2 base. Correct? It's easy for them to run back and forth between the two.
That part we're actually currently working on, but will be released soon as well. Yeah.
Yes. So currently, the supported flow will be from K2 to the designer, but we're working on the reverse option.
Exactly.
Okay, great. And do you have any projections on when that may be available?
I don't have at the moment. I hope that as soon as possible.
Me neither, and the same, yeah.
Because we do see the value in this, so
yeah. So do we, and we got a lot of good feedback on Intersolar. I think Gal as well. And one of the few questions that came up was actually, when will it be available for the way back? So we're working on that one really hard.
Okay, perfect. And then one of the another question that had come in surrounding this shade analysis is, do you have any information on the accuracy of this shade analysis that's put into the software?
Well, Stefan, do you have a comment about the K2 base? Or?
Actually, I wouldn't know that one, but I might be able to get the answer later on. But I think it's pretty accurate as far as I heard from customers.
Sure. And maybe we could work to circulate that and follow up with the presentation as well. Yeah. Okay, great.
Exactly.
Okay, just for the designer, I just wanted to comment about the designer that so far we ran a research, like a test of our simulation accuracy with a company called DNVGL, and we found but currently it was without shading analysis, and we know that our simulation results are as accurate as the PVSys results, up to 1% difference. And we will continue and see how, to either include shading analysis with them or using a different party to check it. But we're quite confident about our shading analysis.
Okay, perfect. That really makes the project much more simpler. Another question, or a couple questions, have come through surrounding setbacks. So, what is there any type of information that's automated surrounding setbacks required for fire codes?
I guess this question goes to Stefan, right? Because this is in this flow, usually the PV layout will be done in K2 base.
Yeah, it does. Setback, could you repeat that one, please?
Yeah, as far as setbacks for fire codes, and when designing on the roof in the software.
Okay, so if it's in accordance with the national building codes and implemented in there, those restrictions and everything have been implemented in the software.
Okay, sure. And then some additional questions that have come through is there a type of CRM that's built into or integrated into this software where contractors and designers would be able to utilize plugins?
Well, for our part, not yet, but I actually like the idea.
Same here.
Great. And are there any type of maximum limits as far as project sizes are concerned, or number of modules, or is it really infinite depending on the roof space that's available?
I mean, infinite from our part, no. I think there's some hard limitations, like if you want to draw a building that is longer than a kilometer, it doesn't work, right? But there's no
Sure.
buildings like that. But in general, you can plan all those buildings with base.
Okay, excellent. And then an additional question that's just come through is, well, actually, looks like we've made it through the majority of the questions. Are there any additional questions from participants? An additional thing that came up is whether you can take different slopes of the roof into account as well. I know we did the demo with the flat
Yeah,
roof.
Of course. If you want to switch back to me, I can just quickly show that.
Yeah, perfect. We'll go ahead and do that.
Cool. So let me just fire up base again. So once we go back to the roof tab, you also have the possibility of adding another roof here, which could then be, for example, a pitched roof like that one. In this case, we have a gable roof, a rectangle, and it's tile. I'm just going to do parts of it now to speed it up. But basically what you can do here is then input the roof pitch for a pitched roof. And that one is basically anything above 5 degrees till 75. And apart from that, the planning process is the same as with the flat roof one. You can then switch to 2D mode, input all the data again. And of course, as this is a tiled roof, you have to input some different characteristics like the rafter spacing and batten spacing. And you can then move on to the design and draw the modules with the different systems that we have here. Because it's tiled, those options are roof hooks. But in the end, the system is as intelligent as to show you what system works with what type of roofing. So it's quite easy to handle that one.
Okay.
Of course, once it's exported to the designer, also it will be displayed, of course, as tilted and everything, just as it was configured in the K2 base tool.
Exactly.
Yeah.
Additionally, participants are also inquiring if it's possible to export systems to other inverter design tools as well.
Again, not yet, but we're currently talking to several major manufacturers.
Sure, with such an efficient tool, I imagine that there'll be lots of opportunities moving forward in the future.
There definitely will be.
And then for larger projects, some financing challenges could potentially come through surrounding media norm, depending on location. And they were wondering if there's any type of functionality to incorporate or use other data, for instance, from NASA or Solar GIS, etc.
Sure, definitely. Yeah, I wasn't sure if it's Stefan, you.
Yeah, you go first.
Okay, but because I guess the use of the meteorological data is mostly for the yield calculation, and for this it mostly concerns the designer and the electrical part also. So our inbuilt weather stations are from the TEL norm, but we already have the option to import. You can just, we have an import button next to the weather station selection. So if you don't like to use the weather station, you can just simply upload a CSV format, file format, using either in a TMY, typical meteorological year format, or we also support the PVSys format and kind of our custom, very simple format where you just include for each day in each hour of the year, the values, the weather values that we need for the GHI, DHI, and the ambient temperature. So you can just load it to the project and run using your custom weather data.
exactly. And for us, as Gail said, for the mechanical part, the weather is not really that important. So we only use shadow and loads according to Eurocode. So.
Sure, sure. And then when actually in the designer itself, is it possible to easily adjust the orientation if you wanted to try rotating the modules of the flat roof so that they were orientated to the south, for instance?
Yeah, definitely. So we also offer in our tool, there are actually 2 steps that we currently skipped because we were able to do it from the K2 base, but we have a site modeling step where we create this 3D model of the house or the roof or the system. It can actually be also ground mount or carport, either a single or multi-oriented system. And then we have a PV placement screen where you can add the modules and easily set different properties, rotate them, set the different azimuth, different tilt, different mounting orientation, portrait, landscape, and so on. So it's definitely can also be done using the designer. But if you are really changing things and you work with this collaboration with a K2 base, for now, I think it's better to do the changes on the K2 base, and we offer the update option, so you can update and the PV layout, and then it will be automatically reflected on your project in Designer. But it is possible, of course, to do the entire module placement also on the Designer.
Okay, beautiful. And then what are those, right, currently, what are the plans for, are there any additional changes or advancements that will be made, or items for the system designers to look forward to within the current system that's just been launched, this product?
Yeah, of course. I mean, I think SolarEdge as well, but we do have a huge pipeline of new cool features that are going to be implemented soon.
Yeah, absolutely. So we're the same. So I think Stefan also mentioned it about the K2 base, but also I can definitely say about the designer that it's like an evolving product. We have our team, excellent team working, adding new features, and we have a very long list of features and plans for this tool. As I mentioned a bit earlier, we're really close to launching our auto string functionality. So I think this is also going to be a huge improvement and a lot more to come.
Okay, excellent. Now we have a couple of more minutes here, and we've worked through the questions from all of our participants. Thank you so much for being engaged. Is there anything additional within your demos that either of you would like to share with the audience that you think might have some outstanding points for clarification? Or is there anything additional to be to discuss that you think that we maybe didn't touch in today's great webinar?
Well, I can go on and on about PV planning and design, but I leave it for Stefan to.
Yeah. I mean, yeah.
This was a simple example, but yeah.
If we want to, we can also do another project just from the beginning to the end, just to show you that one.
That would be great. I think there were a few participants that came in later, so I think that would be great.
All right.
To go over that.
So let's do that then. So I'm just going to start a new project here. And yeah, I know it's something that I might be able to show you, which is actually quite nice. It's a feature that we're currently working on, the roof check that I mentioned earlier in the presentation, where you're able to gather project data on site with your mobile phone while talking to your customer. And once you did that, you will then be able to input the roof data and import it in base automatically to start the planning process. And
amazing.
Just going to go ahead and do one really quickly here. It's a trapezoidal metal sheet roof. We just get the hint that unsafe data will be lost. If we open new project, and what you see here is a pop-up showing different types of roofs, and in this case we only have one, but in case there's a project with several roofs, all of those roofs would be shown here. And you just select the type of roof that you have, you click on draw, then the roof type, the roof shape, and the roof covering are already pre-selected because you did that in the app before, and you just add it and start the planning process as well, right? And in this case, is that trapezoidal sheet roof here. And what you can see now is that unlike before, most of the parts here, most of the building dimensions, the covering, the crest distance, which is actually quite important for trapezoidal sheet, is already pre-selected, right? And that's because that data has been input on site previously. We also have the option, if you see, okay, it might not have been 10, it's probably more than like 11 meters building height. The system is foolproof because the icon showing you that the data was gathered by the app is gone now. So you will know whether you changed it later on or not. What we also did is we added the possibility to have pictures taken on site, adding some notes if you want to have some, which will help you remember that you can, like, let's assume that you're talking to a customer today, but you don't have time to do the planning until end of next week. Usually you either take notes on paper or you don't take any and you think, okay, I might still remember that. But we all know that most of the time you will forget important stuff. And therefore you have the possibility to add those notes, which are also saved and always readily available during the planning process. So once we did that, I'm just going to go ahead and move over to the design page where we can draw the modules again. Let's switch to 2D mode. And there you can also place the module arrays. Now, in this case, as it's a trapezoidal system, we have different options. For example, a speed rail, which has a long rail and a floating suspension. I'm just going to take that one here. Go for portrait mode. If you remember earlier from the flat roof, there was only landscape available due to the system restrictions. In this case, it's possible to go both ways, portrait or landscape. And yeah, I'm just going to draw the module field. Show it again up here. Okay. We got the total number of modules down here. I'm just going to skip the rest because most of you guys already saw that. And then it's basically the same process again. You go ahead, move on to the loads. Those are determined automatically again because it's still a project in Germany. We can then go to the results where we have some more options. Yep.
Sorry to interrupt you. One question came up. Is the roof edge offset automatically calculated according to the height in the wind area?
The offset, you mean?
Yes. The roof edges.
Yeah, they are. Also, if you go to the results page, what we can see here, I can just quickly show you that one. We have the roof zones that are actually coming out of the national building regulations, which we have to consider during the installation. So if I would move the project parts into those edges, like the corner areas shown in red, or the basically the edge area in the middle here in yellow and up here, in those areas, the wind force applied on the structure, being pushed on the structure, is higher. Therefore, we would need more fastening articles in that areas. And as it's a long rail system, you also have the option to choose different types of rail lengths that you just want to do up here, for example. And then it's basically the same again. System verification, also here, everything in detail, everything in order. We can go ahead and choose a summary, where it's same thing again. I didn't show that earlier. I'm just going to do it now real quick. I'm going to generate the project report, the PDF, so you guys have seen that one as well. So that report is, as I mentioned earlier, actually quite important. It's showing everything, the calculation basis that you did. So we have all the project data again that has been input in the tool before. We have a detailed assembly ban showing how to assemble everything. You have the fasteners and also where to put the rails, where to put the speed clips in this case. And of course, the results showing the loads on the module, maximum loads, etc. Plus, as I mentioned, the structural analysis report, which includes a lot of detailed formulas as well. Just in case any of you guys are structural engineer, you can zip through that as well if you want to. And of course, excellent, the bill of material in the end. Yeah.
Great, thank you for that. And I'm happy we went over because we had quite a few people that had missed the earlier part of the demo that requested that just as we went along. We did get some additional questions here at the end, but for all of you participants, thank you so much for being engaged in this process. We're just fresh out of time, so what we'll do is work to get those responses over to you electronically. And thank you so much. I really appreciate your presentation, Stefan and Gal. It was really informative, and it's very innovative that you guys are moving forward with this tool for designers to use in making systems more efficient.
Thank you. You're welcome. Happy to be here.
Thanks. It was a real pleasure.
Have a beautiful day, everyone.
You too. Bye-bye.
You too. Bye-bye.